So let's start. For setup, I have prepared the downloaded zip file and a demonstration program, which is a tiny little assembler program, and the GCL for it. First thing we do is we unpack this, okay, and we unpack the 3 files in it. Okay. Now, as a result of this unzip operation, we have 3 new zip files which we unpack as well. Oh, did that twice. The third one. Okay, and now as a result we have 3 new folders. Now in these 3 folders we have the installation material as well as documentation about it, and now we skip the readme now, but instead we only submit the job that came with it. Okay, and we submit that to VSE, and let's check. Okay, here we come. So we answer that 9. Okay, catalog job successful, and 1 level up, and we submit this. So now we have cataloged the basic product for CICS as well as the batch part, and now we catalog the source support. Now this is also complete. Now we have one more thing to do, which is customize the source support module, which must be adapted to your environment, which is what is the master password for the spool files and how would you like to access it. For this we do it pretty simple. We do nothing. We take the stuff as it is. We edit the 3 files, which is the SPL parameter. What you need to do is adjust the master password. Master password and the class you would like to inspect. If you don't do that, the only user ID, only your own user ID is accessible from Trapper. Here's cataloging subroutine, and it goes to class V. A destination, we don't need that. Okay, and when done, you submit it to VSE. Okay. And the next thing is there's a TRAPPER02, which is an exit which gets control once everything is determined to access the spool files, and you can do final changes in that coding. For this here we do nothing and just submit it to batch. Again, we don't need the destination. So we remove that and submit it to batch, and again a subroutine. You can see that here down. Switch and then catalog as TRAPPER02 and submit. Okay, and when that is done, you have to control that the compiles went okay. Once this is done, we have to link the source support module with the two subroutines and of course the CICS stub, and that goes again without destination, and we submit that. And now control that it's okay, and I know that it's okay. So next thing is to adjust CICS so it accepts the programs as being valid members of the CICS family, because the human interface for Trapper, both batch as well as CICS, both run in CICS, so you can talk to them on the 3270 screen. Now that we have the batch preparation completed, we do some preparation in CICS, and these are only one-time activities. One more little step and then, okay, we go into CICS. Okay, and into native, and we start CEDA, and I have prepared a group. No, sorry, expand group demo. Here's the group I have prepared, which is for two transactions, which is for the batch, nothing special, just this program and this transaction ID. And I also have the other one, which is for online, just the program, nothing special. Everything system takes care of itself and looks that everything is set the way it is. There's no need for defining any programs, because I have auto install for programs active. If you don't have that active, you have to define TRAPPER-CIC and TRAPPER-C and TRAPPER01. Now once everything is defined, we have to install that, which is done now. Installed successful. Okay, we end the transaction and we are ready for a debug session. Okay, we start with the demo program, which is here. It covers a problem that was discussed in January and February of 2022 on the assembler list, and the code I will use for the demonstration is from Dave. The unit code is from me, simply because I'm lazy. Now what I do with that code is compile it, send it to VSE, and we'll look at the code. Three batch queues, list queue, demo. Okay, the first one is from me preparing it, or looking at it. Okay. And link is okay, and that's it. So now we can start. starting a debug session. Yeah, we start with some GCL. Here's the GCL for that demo program. It's just an exec demo program, and we wouldn't see anything unless we insert some WTO or some other means to inspect what goes on. Now with Trapper, you can just replace the exec by TRAPPER01 and whatever parm you have or whatever other parameters, and you need a set parm statement which tells the original program name, which is demo program, and you tell it where CICS is, and that's it. And one thing, it only works in F4. It's a long story behind that, but no one has complained so far about that. So we submit that, and then we can go into a session. Escape from here, and we start trap. Okay, this is the basic batch debugger, and you have memory content, the very first instruction of the program, the registers, and down here you have two lines which show you the meaning of the various PF keys. And there's one thing which is special, which is alternate PFs. You press PF1, do that now, and it changes the meaning of the PF keys to a second meaning. Okay, we go, and we have stop at cursor, which is stop at execution at that. Here we have some special commands which become important at various points in time, but usually only once. Then we have PF4, which goes to the previous display area. PF5 goes to a certain address. F6 decodes the instruction at cursor. 7 goes back, 8 goes forward. 9 is single step, which step by step, or go is go till you hit a trap. Now the alternate are alter memory, go to a certain location, to a certain address, help, the commands help for the display, but there's also a PDF file for this. Flip ASCII EBCDIC, which is pretty nice if you're debugging programs which are supposed to produce some ASCII output. Backward, forward, single stepping, and go. Now there's eeny tiny little thing, the plus sign here, that is very important. That is for the PF11 key, and it does have a meaning now, which means you can go into source debugging because you found the source of the program, which is a demo program. You found the source of that under the specified ID in the spool files. So we press PF11 and are in source debugging. Yeah, it's the listing, and you can use the same, almost the same keys as in the basic product. And if you don't remember the keys, we have PF1, which is show me help. And here we have only one meaning, so PF1 switches help on and off. Okay, help on and off. Then we have set a stop on a certain location, return to basic debugging, which is the other thing, trim, which is separate the screen on different locations. This is pretty important. If you would like to inspect memory, you put the cursor down here, for example, or here, and you get a bigger down window, which is good if you would like to look at memory. Now to go back to normal, we put the cursor down, pretty much down here, and okay. And we have show. Show is show me what is here. For example, you can go on that and use the show key, and it will show you what is in there. Doesn't make much sense right now because we're at the start of the program, and we should let it run a few lines, and we'll do that in a second. 6 is move focus, which is this line. You can move that down here, or you can move it up there. Backward, forward is forward, forward. A single step and go. Now, good thing to demonstrate the meaning of the PF5 show key is to go past the loading of the base address, which is here. Loading of the base is here. So we tell it to stop here, and okay, it says successful, and we tell it to run there. Now it stops here, and now we can use the F5 key to do a show here, and it shows us the content, the memory content at that location, or here. Oh, okay. Make sure that the cursor is there, not only the focus line. Now single stepping, you can inspect whatever you would like, and you can also inspect the registers. If you enter R, PF5, you see the registers. Now with the registers, you can also go and put the cursor on a register and use the PF5 key to show what is at that location if you want to. Now let's make it real, and it is of interest what happens with the register, namely register 0 and register 1. And for that we first look at the content of byte which is loaded, which is E0, and now we'll look at the registers, and we go do it step by step first. Okay, now we have an E0 in the high order, we have register 0, we have E0 in the high order. We shift that right by 30, and we have a 3 here, which is all we need of that register, and register 1 is of no interest at all, except the first 2 bits. Now we shift that to the very end. Okay, and we have a 3 and a 2, and that should yield a 4 and a 3 in EBCDIC. Now let's see. Register 0, we have an F4 now here, and we have an F3 here, and it's stored in target, and we can watch that. Stored. Target 1 is the other one down here, and you can see the relative offsets here. And now we clear register 15 and leave the program, and that's it. Here we can see the special commands, PF3, and we have switching on for logging of instructions, terminated, dump at the point where we are right now, which is not what we want to do. Instead we want to go exit from Trapper and let the program end. Yeah, and this is what we do. End it, and the batch progress should end as well. End at 0. That's all. Yeah, this is what we'll do, what I will do in the next clip. Thank you for watching. Bye.